Okay guys, so today's lesson is on section 10.5, and this is the last section we're going to cover, although we do cover 10.6, but I actually have brought it in already, and you don't even realize that we've been learning it. But just to review, we've talked about a circle as a set of all points equidistant from a point called the center of the circle, and we know it looks something like that. We know that it's got a part and it's got a radius, okay? An ellipse, we talked about, looks more like an oval, kind of like the solar system, okay? It's actually a reflection of the moon. Anyways, so it's a set of all points such that the sum of the distance of two fixed points called foci are constant. So I talked to you about these 2 points inside it that are called foci. And if I put any point on the ellipse, and I draw lines to those foci, no matter where that point goes around the ellipse, the distances, the sum of these two distances will be constant, okay? All right, but today we're going to take that a little bit further, and we're going to be talking about hyperbolas. Now, we actually have talked about hyperbolas before, but we're going to be doing a different type of hyperbola, okay? So, today we'll define a hyperbola. That's a fill in the blank. And so that I know you're watching, how about a big smiley face? And it does have some similarities to an ellipse, so that's where we're going to have to be very, very careful. So if I haven't said this before, this is in particular one lesson you're going to want to pay close attention to. Okay, so first of all, a hyperbola, and you have this in your notes, is a set of all points such that the difference from P to two fixed points, again called foci, is constant. So here's a hyperbola. It's these two curves, okay? These two lines going through the origin are asymptotes, and where they cross is the center, okay? The foci are on the inside of the hyperbola, okay? But if I'm to draw a line from the focus to any point P on the hyperbola, the sum of the distances, okay, the distances from P to F, if I subtract their distances, it's going to be constant no matter where I travel along the hyperbola. Okay, along this one or along this one, okay? Now, there's some parts to it, and I'm going to draw them in, but you don't have to. I just want you to know about them. The line joining the vertices. This line joining the vertices is called the transverse axis. Transverse axis. Okay? And this one is a horizontal transverse axis, but we can also have vertical. Kind of like the ellipse was vertical and as well, okay? All right, the center is the midpoint of that line, right there. The hyperbola has two asymptotes, which I've drawn in red, okay, so you might want to highlight. And the asymptotes actually contain the diagonals of a rectangle centered at the hyperbola's center. And I'm going to get into that in a second, okay? So, you have to understand what a hyperbola looks like, and that it looks slightly different than the hyperbolas we've done before. Okay? If you recall in chapter 9, James was just making fun of me from outside the window. So anyways, if you recall, in chapter 9 we graphed hyperbolas, and they looked y equals 1 over x. You might remember those. That is the graph of a hyperbola. It was called a hyperbola, and it is a hyperbola. But those rational functions have very specific asymptotes, vertical and horizontal. And if you remember, we had y equals 0 and x equals 0. So those asymptotes went like that. Ours are not in this hyperbola. They're going to be going like that. So they're not going to be as easy to find those equations of those lines, okay? All right. So let's talk about it. A hyperbola with a horizontal transverse axis. Okay, so first of all, I want you guys to go ahead and plot a point at the center of the origin, okay? And that's going to be the center of our hyperbola, okay? And if it's got a horizontal transverse axis, that means there's a vertex here and a vertex here, because the line joining them has got to be horizontal, okay? All right. So we know then that we've got something going like this and something going like this. All right, let's look at the equation of a hyperbola. Now this is where it gets tricky. The equation of a hyperbola is, for a horizontal, is x squared over a squared, and I'm short, look at me, equals y squared over b squared, and it's equal to 1. Okay, so first of all, it's minus in the middle, okay? But here's the interesting thing about hyperbolas. The a and the b never move. The a is always going to be here, and the b is always going to be on the right, so left and right. A is going to come first, then b. What's going to change is the x and the y. And the fact that the x is first, that means that the a's are along the x-axis, okay? So you've got your equation. It's horizontal because x squared is first in the equation. Okay? And then we have our vertices. Our vertices in a horizontal are going to be these points right here. We're going to call them negative a0 and a0. Okay? Our foci, another thing that gets crazy. There's no co-vertices on this, okay? But the foci, to find the foci, it's c squared equals a squared plus b squared. Ooh, right? What does that look like? That looks like the Pythagorean theorem. So we've got to be really careful. So yes, it is the Pythagorean theorem. And then we've got our asymptotes. Okay? And remember, an asymptote is a line that the graph's going to get really, really close to but can never touch it. So you have to be very careful about that, okay? All right, so there is an equation for the asymptotes. Y equals, if it's horizontal, b over a x. And think about it like this. If we look back at that question, it's always, when we do lines, it's always y over x, right? Rise over run. So it's always going to be the number under the y over the variable under the x. Okay. How do we find that? Well, the one thing I want you to realize is that the first thing we're going to be doing is we would label our b coordinate along the opposite axis. So I'm going to go do that. 0b, negative b, and 0b. Okay? To graph it, we would then create a rectangle going through all of those points, the a and the b. Okay? The asymptotes are going to be lines that go straight through. They are the diagonals of that rectangle. Okay, so they're the diagonals of that rectangle. I know mine's getting kind of messy here. Okay? Then we have our vertex, so we can take our pen and we're going to make a curve until it gets really close to that asymptote, and then it turns. Now the same thing's going to happen here. It's a curve. It's getting really, really close to the asymptotes. It's not going to touch it. And then we know our foci. We're going to get our foci, and it's going to be C, and it's going to go right here inside the hyperbola. So negative C0 and C0. Okay? All right. So looking at the vertical hyperbola with a vertical transverse axis, it's very similar, but it's going in a different direction. So our vertex are going to be at 0A and 0, negative A. Okay? We're going to have B along the x-axis. So we're going to go B0, so negative B0, B0. And that's similar to what we did before, okay? All right, we're going to create a box with those points. A rectangle, right? We are going to draw in our asymptotes, and then we're going to make our curve go really close to those asymptotes but never touch it. We're going to then find our focus, and it's going to be, oh, and I did this, darn it, did the same thing, I graphed it wrong. So let me go back. Sorry about that, guys, so pause. I knew that looked fun to me. So I'm glad I caught myself. Okay, so that's why it's got to be really careful. You want to do these in pencil. So there's my box again. Sorry about that. And I'm going to go from here, like that, and then from here down. Okay. Okay, and then my focus points are going to go on the inside of the hyperbola. But let's just make sure you have everything you need for this particular equation, okay? You need your equation, which is y squared over a squared minus x squared over b squared equals 1. Okay, so now the y has come first. So that's what tells me that it's vertical, okay? Because it means I'm going along the y-axis, okay? So it's vertical because the y squared is first.